Hey guys, we are in chapter 8 and we're looking at linear functions and graphing. This section is really important. I want you to pay attention. We're going to see this again in Algebra 1 and you're going to need to have this foundation to make sure it makes sense when you see it again next year. Here's the deal. We're going to talk about writing linear equations. So we're going to get little hints about about a linear equation. We're going to be able to write it. What you remember from last time is that we had the power to write linear equations in something called slope-intercept form, right? Slope-intercept form proved to be rather useful because it's y equal mx plus b, where m and b are super duper important. And the reason why they're so important is because m is the slope and b is the y-intercept. And why that's awesome, intercept, and why that's awesome is because if we have an equation in this form, we can graph it so easily. We just go to the y-intercept, we go up, over using the slope, and it's great. So we like this form, and sometimes students like it so much that they stick to it and they use nothing else. And that's not bad, but that's not always going to be helpful. So today we're going to talk about a new form that is very helpful, and I hope you start to feel comfortable with it. I'm going to shrink this away a little bit. And so this brings us to our first vocabulary term. Our vocabulary term is point slope form of a line. So you guys remember we said, this is kind of a thought bubble here. You guys remember that we talked about the slope of a line as m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We called that change in y over change in x. Well, what happens is we could multiply both sides of the equation. This is an equation. We can multiply both sides of the equation by x sub 2 minus x sub 1. And when I do that, I'm going to do it like this. X sub 2 minus x sub 1. Do both sides x sub 2 minus x sub 1. When I do that, these guys cancel out and I'm left with this. In essence, I can rewrite it. I'm going to put this side on this side. So y sub 2 minus y sub 1 equals m times x sub 2 minus x sub 1. Why am I bringing this up? Well, this is really where we get our next form of an equation from. The next form of an equation we're going to talk about is called point slope. And point slope is when you take y and then some y coordinate, so we're going to call that y sub 1, and then we take the slope and we multiply it by x and then the x coordinate of the same point. So this is another form of an equation that's really helpful. The beauty of this equation is that we again, wrong marker. We again are using the, let's use black. We again are using the slope, but instead of using the slope and just the slope, we're going to use the slope and a point. And this x and y refers to a point. Okay, so with that, let's go on to our first example. So here's our first example. It has two parts. We're going to write the equation of the line. Notice the form that we are being asked to use. We're writing the equation of the line in slope-intercept form. I think there's a hyphen here. In slope-intercept form. So we know slope-intercept is not the new one we just learned, but it's the one we learned last time, y equals mx plus b. Super duper helpful. So we're gonna write an equation of a line in this form given this information, and then we're gonna write an equation of a line in this form given this information, just the graph. So here the slope is 1/2 and the y-intercept is -5. I hope you guys feel like this is really easy because this is pretty straightforward. Y is equal to, what's the slope? 1/2. So let me put it in red. 1/2x. Right? We just put the slope right there for m, and then let me make m back. And then we're going to add to it the b term, which is -5. So our equation ends up being y is equal to 1/2 x minus 5. And that's it. We're good to go. Okay? So that's our answer for this one. Now, let me use green. We need to find an answer for this problem here. So it was really cool that we had the slope and the y-intercept, right? That was pretty awesome that we had those two terms. So if we could find the slope and the y-intercept, we basically have the equation of a line in slope-intercept form. If we can find the slope and y-intercept, we basically have the equation of a line. I'm going to say it again. If we have the slope and y-intercept, we have the equation of a line. So it behooves me to look for the slope and y-intercept here. So that's what I'm going to do. So looking carefully, the y-intercept is where the line crosses the y-axis, and I got it. The y-intercept is going to be positive 4, right? 1, 2, 3, and 4. All right, good. So the next thing we need to do is find the slope. The best way to find the slope when you're looking at a graph is to look carefully at where the line crosses known values. So to me, I'm really confident that I know that this 0, 4 point, right, is being crossed. And I know over here, this 3, 0 point is being crossed. This 3, 0 point is being crossed. So I've got 2 points, and 2 points, pretty easy to find the slope. I can rock a rise over 1, change in y over change in x. Since I got the graph, I'm just going to use it. So if I wanted to move from this point to this point, I'd have to go up 1, 2, 3, 4. So I've got a rise of 4. Sorry, I keep activating something weird on this. I've got a rise of 4, and then my run is actually in the negative, well, maybe whatever way you see this, is in the negative direction. And so I've got to consider this guy here. And so this is a -3 because I'm moving back 3. My slope is rise over run, so my slope is going to be 4 over -3. Or -4/3. Somebody right now is thinking, shall I change this into a mixed number? No. I like improper fractions. They work better for algebra. You'll see that as you continue to work. So reduce it as much as possible, and in this case it is, and just rock the improper fraction. So then we're going to have +4. And that's it. That is our equation. So what's the key point in finding the equation? You really want to find the equation of a line, especially when you got to put it in the slope-intercept form. You need the slope and you need the y-intercept. You got those, you've got the equation of a line. Let's look at another example. So example 2, that felt like 2 examples, but it had 2 parts. Example 2 is giving us less information. They're saying write an equation given 2 points. Find the equation of the line that passes through 4, 8 and -2, 5. So right now you're like, I don't know what to do. You didn't give me a slope. You didn't give me the y-intercept. I don't know what to do. I don't know what to do. And so we can, again, honor this form, y equals mx plus b. So I'm going to show you a method. I'm going to show you 2 methods, right? We can honor this form, y equals mx plus b, by doing exactly what we know, find the slope. Well, to find the slope, we know we've got that fancy-pantsy y sub 2 minus y sub 1 over x sub 2 minus x sub 1 thing rocking for. So we're going to do that. I'm going to find the change in y's over the change in x. This time I'm going to say 8 minus 5, and then 4 minus a minus 2. So 8 minus 5, that's my change in y, and then 4 minus a minus 2, 4 minus a -2. And then so what I end up with is 3 over 6. So my slope is 1/2. Woo, that's done. But what about the y-intercept? Where's that? Well, we're going to actually find it. We're going to use this equation to find the y-intercept. And we'll do that by taking all that we know. So we got y is equal to 1/2. I'm putting in the slope. X plus b, b being the y-intercept. We need to find it. So you're sitting around, you're scratching your head, but then you realize you've got 2 points. If you plug in either of these points for x and y, either 4, 8 for x and y or -2 and 5 for x and y, you will get the same b value because both of these are on the same line and we've used the slope. So I'm going to take 4, 8 just because it's first, doesn't matter. I'm going to take 8 is equal to 1/2 4 plus b. So now I have an equation with just b as the variable, so now I'm going to be able to find the y-intercept, which is what we wanted. So 8 is equal to 1/2 times 4 is 2 plus b, and clearly we can already see what the answer is, but I'm going to solve it anyway. So 8 is equal to 2 plus b, subtract both sides by 2, and we get that b is equal to 6. This is not done though. We are not done. The final portion of this is we need to actually write the equation because that's what they asked for. So y is equal to, what's the slope? We found it to be 1/2. 1/2 of x plus 6 because that's our y-intercept. Wasn't that kind of classy? It was classy. All right, let's talk about another way of doing this. So we found this really new and hip and cool form of an equation. We called it point slope. So we've got listen, point, slope. They tell you the two things you need. You need a point and a slope, and you got it. So let's go ahead and do that. So point slope says y minus some y sub 1 is equal to m, that's the slope, times x minus some x sub 1. And these guys, as I said last time, refer to, let me see if I can point out what I'm talking about. These guys, y sub 1 and x sub 1, just refers to the x and y coordinates of a point. So going back to what we were talking about, I can do y minus, either point will do, but I'm going to focus on this one just because it's first. It doesn't matter. I could use this one, but y minus 8 is equal to, what was the slope? We found it over here, 1/2 times x minus 4. So let's go ahead and simplify this and see if we can put, so this is sufficient, by the way. We're done. But I want to see if it's really the same kind of line here. So I'm going to actually solve for y and see what happens. So y is equal to, I can add 8 to both sides. Probably wouldn't do it in this order, but y is equal to 1/2 x minus 4 plus 8. Let's go ahead and rock a distributive property here to simplify. So y is equal to 1/2 x minus 1/2 times negative 4 is going to be of negative 2 plus 8. What do you see there? Y is equal to 1/2 x negative, what, plus 6? Same thing. So what I want you to see is that, and I know I'm going to use 4, 8. I just didn't want to like kind of beat you over the head by doing it with every point. But if I use negative 2 and 5, it would come out to the same 6 as a y-intercept. If I use negative 2 and 5, eventually this equation would look exactly the same. Both methods are acceptable and fine. Okay, so let's see. We've got another example here. We need a table, so let's get that. Boom. Okay, there we have it. So here's our table, and I finished off the directions. It says write an equation from a table in point slope form. So that's the form we're going to use, and here's a table. Now, since we're writing this in point slope form, we know that we're dealing with a line, and we know that all of these points are on the line. So we literally can take any 2 points that we like and do this problem. So the first thing we need to do is, so first, let's find the slope. And we're going to find the slope by taking any 2 points that we like. And I'm just going to say this one here and this one here. It doesn't matter. Any 2. This one, we could have any 2, right? I guess you get the idea of any 2. So what I'm going to do is find the slope. I know the slope is change in y over change in x. So I'm going to do my change in y. That's 4 minus 1. And I'm going to do my change in x, 12 minus 8. When I do that, I have 3 over 4, so my slope is 3/4. So I've got one portion of this. The second thing is the easiest thing. Second is to choose a point. So I have the choice of 4 points. It doesn't matter which point I choose. I can choose any of these points and I'll get the answer that I need. So I'm going to just choose the last one just for kicks and giggles because I didn't use the last one before. So let's just use this one. It doesn't matter. I could have used one of the same points. All of it would have been fine. So now if I'm going to choose the point 16, 17, I'm going to pull out my point slope form, which I remember to be y minus y sub 1 is equal to m times x minus x sub 1, where y sub 1 and x sub 1 refer to the ordered pair of the point. It refers to a point, blah. And so we have y minus the y term 7 is equal to the slope 3 over 4 times x minus 16. I'm going to simplify this a little bit. I can, so I'm going to use point slope to find this, or I can stop here. This is point slope, but I'm going to actually simplify this a little bit just to make sure that it's nice and organized and simplified as possible. So I'm actually going to take point slope and I'm going to turn it into y equals mx plus b, because we just love it so much. So, and I don't have to do this always, but I'm choosing to do this now. So I'm going to distribute this through. So I'm going to be left with y minus 7 is equal to 3/4 x. Now 3/4 times 16, or negative 16, is going to be a negative. Now when I think about this, I could do 3 times 16 then divide by 4, which is totally legit. But since I know that 4 goes into 16, and that seems easier than doing 3 times 16 for me right now, I'm going to go 4 goes into 16 4 times, or 4 goes into negative 16, negative 4 times negative 4 times 3 is a negative 12. So with that negative 12, I'm going to add 7 to both sides, right? Because that distributed. Okay, so 12 plus a negative 7 is going to give me a negative 5. Let me get rid of that. And I'm done. Guys, I hope this made sense. I look forward to talking to you soon. And let me know if you have any questions. Take it easy. Bye-bye.